Hello, this is Mike at Gamefromscratch, and welcome to another in the ongoing Closer Look at Game Engine series. The entire idea behind this is to give you an idea if a game engine is right for you. It combines the best of a review, a preview, an overview, and a getting started tutorial. So you can spend a half an hour to an hour with me and get a good idea if a game engine is a good fit for you, as opposed to spending 2 or 3 weeks yourself playing around with it and deciding if it fit. So hopefully it's a huge time saver. I've done this for a number of different game engines. I'll link down below to that for each one. I also do a text-based version. It has all the source code, covers most of the same material, just obviously using text instead of listening to my brilliant voice. If you prefer to go that route, again, the link down below. Hopefully this proves useful to you. Now to flip back to Duality. Duality is the engine we are covering today. It is an MIT licensed open source C# based 2D only game engine with a Unity-like editor. A lot of words there, but there's a few catches also. And this is an engine that I owe an apology to start with. You see, a couple people have recommended Duality to me in the past, either through emails or Twitter or on Reddit. I've gotten suggestions basically saying, have you checked the Duality engine? And truth of the matter is, I did, sort of. I looked at it for a minute or two, kind of took a browse through what was available, and went, nah, doesn't matter. And then kind of moved on. I never really looked at it that much closer. And there's a couple reasons why I came to that conclusion. First off, even just trying to be a 2D only version of Unity is no small task. Like, that is an incredibly complicated project to set out to do. And Duality is essentially one developer. So there's a lot of people out there that look at something like Unity and go, oh hell, I can make a 2D version, there's no problem. They start the project off, and 4 or 5 months later, it's abandoned and gone. Now, Duality's been around for years, and it's a very refined engine, so that part never happened. I have to very much applaud the developer behind it. He's done an amazing job. The other reason why I discounted it was it's Windows only, and that is, in this day and age, a deal breaker. Now, fortunately, that has changed. In the last couple of months, he finished porting all of the core code and plugins to being portable class libraries. The PCL standard basically is a minimum implemented set of the class library. So but you're using a subset of .NET that's guaranteed to be portable. So now that Duality itself, the core of it is all PCL based, that means it can run on anywhere that has a valid modern .NET runtime. So you can port it to Android or iOS using Xamarin. You could run it on Mac. You could run it on Linux using Mono in both cases. So portability, cross-platform portability is not an issue now. So bravo for the developer for changing that, and that's a big part of the reason why Duality is now viable. There is a gigantic gotcha right up front though. So I'm going to tell you the biggest flaw with Duality, so you don't really need to continue on if this is a deal breaker for you. The tooling is Windows only. You still need to run the editor on a Windows machine, and it requires Visual Studio 2013 or later. So if your development environment can't include Windows, or you're not running something like Parallels on a Mac, Duality doesn't work for you. So right up front, if you're a Unity developer, sorry, this is not the right engine for you. Fortunately, you can target all those platforms now, but the tools are Windows only, and probably will be for the foreseeable future, at least for a while from now. So right up front, that is probably the biggest negative. Now, the biggest positive, I really like Duality. It's a great experience. I highly recommend it. So a bit of a spoiler there. This engine impressed the hell out of me, and I wish I checked it out a long time ago. Now, the truth of the matter is, until he finished that portability bit, until he made this game engine so that it could run on all those different platforms, it still would have been a toy at best. So now that it actually has that cross-platform ability, this becomes a very viable engine. And as you're about to see, the tools behind it, the code behind it, everything that's behind it, the word that comes to mind is polish. This is a very clean, I was shocked. This is the kind of project that normally is the opposite of polished. Completely shocked me here. So let's jump on it. And here's the Duality homepage. It's duality.atomslayer.net. I'll link that in the comments down below too. or on Gamefromscratch. Actually, go to Gamefromscratch. It links back. Plus, it has all the source code, etc. So I'll link everything from there. But this is where you can download it. Just come in here and click this guy. I'm not going to do it right now because this is actually a direct version. This is the file. It's a zip file that gets downloaded. It's about a megabyte in size, and it's actually a downloader, essentially. So when you download it, dun, 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 I've already downloaded it a couple times, but when it comes down, you will see it contains a folder and then the editor exe and a couple DLLs, and that's about it. Now what you want to do is you take that folder and extract it somewhere. Like so, and then the first time you run it, it's going to pop up and say, do you agree with the MIT license? And then download the required bits. There's about 100 megs worth of stuff ultimately get downloaded or generated. I'm not sure. This downloads pretty quick, so I'm assuming part of it's being generated. But when you're done, you end up with about 120 megs worth of stuff in that folder. And here is the editor loaded up. I'm going to flip back to that folder for a second. And the important thing here is Duality as a framework, as an SDK, as a game editor, as a game engine, as a game project, and your game project itself are all one thing. So if I go back into the editor and go file new project, I will get an entire copy of all of this again. So there's a tight coupling between your code and the editor. And your code is actually a DLL that runs within the executable. The Duality launcher right here is bootstrapped your code. Don't worry, it's not a limitation at all. Don't be turned off by that at all. It actually it means your code runs really, really, really well inside of the editing environment. The coupling between the two is some of the best I've ever seen for a game engine. There's no fiddling, you build it and it links. So there's definitely an upside to the approach they took, but just be aware that your code exists within an install. And this is going to be a bit of a challenge for upgrading to new versions or collaborating with other people. Now, it's not that big of a fight because you could just do, each one of you installs to the newest version, and then your code exists in this source folder right here. So core plugin, editor plugin, we'll see those in a moment, but this is ultimately your solution file. This is where your code resides, but it is in this subfolder of this entire hierarchy that includes the engine and everything else. That is essentially your project file. There is no, I can't go ahead and create like a small stub project file. I will get all of this stuff again. Okay, so just one of those things to be aware of right up front. Now let's jump over to Duality itself. And this is it. I'm going to do a quick preview or a quick review of what you've got here, and then we'll move on to actually using it to create some entities. Now, over here, basically this is your world editor. This is where you compose your scene, place things within it, etc. But it also pulls double duty. You've got your game view, which if you've used Unity, it's sort of like a not quite full running version, but more advanced than looking just at the results in the browser. You'll notice up here we've got the preview buttons that we had beforehand, that you also have in a Unity type editor, which allows you to sort of run your game logic and see how it will work and react. We'll see that all in action in a bit. And on top of that, you also have a rigid body editor. This is for editing physics shapes. We'll also see that in a few moments. But essentially, this left-hand side of the screen is where you compose your scene. Now, the nice thing about actually it's called Dualiter, is about the editor itself, is it's so configurable, customizable. You'll notice here we have this camera angle. I could also go ahead and create another one. So now we have two tabs. I can take this tab and float it like so. So we could have a running copy of the game running off on a separate monitor. We can have the physics editor open. We can now take this guy back and dock it to the right, so we have a split screen view like so. You can kind of arrange it however you want. So the interface itself is as configurable as you want. You'll notice that's the case over here too. You can pin, unpin. You can close down completely. You can drag up here and undock, move things around however you want. So it's infinitely customizable. It's very multi-monitor friendly, which is a very, very cool thing. So your world editing goes along over here. You got a couple other settings. You can toggle things on, off, change your grid, have grid snapping, etc. That's what your top toolbar over here does. This guy right up here, this is your preview controls. This is to debug your game, this is to build your game, or this is to open your game over in Visual Studio, which again, we'll see all of those in action in a little bit. Now, next up, you've got scene view. This is basically your scene graph. Your worlds are made out of scenes. Scenes can be analogous to screens if you want to go that route. You could have one scene for your entire game. You could do your scene being your level, but it's the basic building unit of containing world stuff. And by default, you have one object within your scene, which is a main camera. Now, like most game engines these days, it seems, the Duality is component-based. So your scene is made up of game objects, which in turn are containers for components. So, for example, main camera is a game object named main camera that has 3 components: a camera component, a sound listener component, and a transform component. And we can add new ones here by right-click, new, and then just picking either game object, or you could do the component directly. Now, we'll come back, we'll see that again in a second. Down here, you've got your project view. Your project view is where your world assets are. I would have been better named asset view in my humble opinion, but this is basically the things that go together to make up your project. Things like textures or sound files, etc. You can see there's a number of things built in right here in the default. That's why it's grayed out. We can also bring new things in by drag and drop, which we will also see in a moment. But you see right underneath, there's a set of vertex shaders built in for you, a bunch of textures built in, included fonts, audio data, etc. So this is the stuff that's built in as part of the engine itself. And we can add our own of all those different types, and it automatically imports them when you drop them in, or you can do new and bring them in this way. We can also do prefabs, which are basically you set up and you configure a game object in the scene, and you can kind of then create a prefab of it, so you can rapidly re-instance new versions of the same thing. Again, if you've used Unity, you've probably run into prefabs, and it all makes sense to you. Now, the other guy is this guy over here. Both of these guys are actually dynamically driven based off of what we're currently doing. So if I select the camera, you'll see over here in the Object Inspector, the 3 components are editable from that camera. So I can span this out, and I can set the properties for the transform component, for the camera component, etc. Whereas if I select something here, like an asset, so for example, our font, it instead shows the values we can configure for the font. Since these are built in, they're all grayed out, we can't actually change anything. But if I brought in my own TTF file, we could make settings and changes here accordingly. And you also see they've got this nice preview window going on up here. It's dependent on the object you bring in. So here's an image instead. You'll see the settings all change. So this is where your properties are set. Now, what your properties are setting of changes dynamically based off what you currently are using. Now, the other cool thing is this advisor right above, which is basically an Uber tooltip. So as you highlight over something, it dynamically figures out what you're talking about and gives you advice on it. So camera, if I hover over camera, it gives you the text of what camera is. So if I hover over this window, it tells you what this window is for and what the shortcuts are. If I hover over scale, it tells you the okay, I'm over transform apparently, but it gives you the, there. So if I hover over scale, you can get the comment that's attached to that underlying variable. So it's a context-sensitive help tooltip-y approach. And that is essentially your editor. Now let's put it all together and make something. Now the very neat thing, let's do something from scratch. We're going to create our own component, just a sprite component, and we'll show all the various pieces involved. We'll just new game object. So we have it, and we'll call it my sprite, like so. And now we're going to add a sprite renderer to it. And you see automatically it attaches this built-in sprite for us. So we're going to go ahead and change that in a little bit. But you can immediately see it also brought in a corresponding transform component because the sprite renderer has a dependency on that component existing. And if I go to get rid of the one, it's actually going to tell me that the other requires it. So we could just keep adding components as we wish. And we're going to add one more in a little bit. But that was it. That was all that was really involved in creating this sprite instance. Now we're going to go ahead and we're going to add our own sprite to it. And that is, okay. So I need a picture. Oh, I've got my navigation turned off. Okay, this is really confusing. 1 second. Actually, 1 second. All right, I have my navigation turned off. That's very confusing. So, want a picture? I'll go with this amazing one right here. So just bring in whatever compatible format it is and drop it into your project view. And it automatically figures out what it was. So you can see it brought in this PNG file and it automatically created a pix map. And here you can see with it selected, the Object Explorer shows the image editor. And there's a couple settings we could set here for columns and rows if it was a sprite sheet as opposed to a single sprite. But now we're going to go ahead and set this sprite as the active sprite on this component. So select this component, expand it out here, and you see down here there's this shared material. And all we want to do is just drag this guy over here and replace it. And that's it, done. We now have it defined, and you saw it updated immediately over here, but you also notice that it created two other objects for us. We could also organize this into, so I could go so it doesn't get too messy too fast. But you'll see here that it created, so the pix map was created immediately, but when we instantiated the pix map, it went ahead and created a texture and a material definition as well. And when we highlight one of these, you can see the different values here. So the texture is essentially the texture mapping. This is how we can say how to filter it, how to, we can change the size of it, we could wrap it. So instead of, if it was a brick texture and we wanted to like tile it across our image, we could do that. With changing our wrapping to repeat, etc. So this is basically your UV settings definition for this instance. And then over here we've also got this material. And the material, in this case, isn't doing a whole lot, but it's setting a default drawing technique. And this is where you can start to see some of the power of Duality and the details that's actually hiding from you and how much more advanced you could go with this. So say you wanted to attach a shader to this instead. We had changed this all right here. So you see the technique, the draw technique by default was this guy. Right here. Now we can just click here. So it's default draw technique mask. So we go back into default draw technique and I can select it right here like so. So it's using a built-in drawing technique called mask. And there's no shader attached to mask in this particular case. So coincidentally, I could have done the same thing by clicking the eyeball here, and it would have automatically gone and selected it over here. Now let's say we went with this guy instead, picking, as opposed to mask. You'll see that there is a shader attached to picking. And we can click here, and then it goes to the shader program that's attached. And the shader is composed of a fragment and vertex shader, and a set of fields being passed in. So if you've done any GL shader programming, you can see how the GL shader is being linked to the editor, but it's all being done for you transparently behind the scenes. You can dig in, you can add this detail if you wish, you could create your own shaders if you wish, but you don't have to, it's all hidden away. But it's accessible right here in the editor. So if I want to come back here, so let's say this is a fragment shader being attached if this particular draw option is chosen. Click here, you see it's chosen this fragment shader. We click the shader, and then ultimately we end up in a text editor, and there is your shader being applied. And there is, oops, that parameter being passed, which was defined here, I think. Yep, there. So there's how you could also go ahead and tie in, bring in your own custom shader and just change it right there and you're done. So the editor has made it so dropping an image in is literally just a matter of drag and drop, but it's also exposed the underlying OpenGL functionality in such a way that you could quite easily, the world's the limit, the sky's your limit. So it's not dumbing it down, it's making it easy, but all of the underlying guts are still there, still exposed to you. So they've done a very slick job there of hiding the complexity, but still making the complexity available should you need it. Anyways, so that is what's involved in creating this entity. Now to show you something otherwise, let me just go ahead and kill our sprite off instead. You could have also done the same thing, but just dragging it into the scene. And you'll notice it went ahead and created a new game object with the name of your source and automatically created a sprite renderer and the transform settings. And now let's look back to their editor for a second. So we're in scene editor mode, and you will see by default when I'm inside of the shape, if you look really close, my cursor has a four-way arrow hat thing going on. I can now manipulate my position accordingly. And you'll notice up here, these values are being set. So as I move around, those values are scaling. Obviously, z-axis coordinate isn't scaling, but it is available to you if you want to do depth layering type stuff. Or you can edit directly through the inspector, like so. And then on top, and this is one of the nicest widgets I've seen for 2D, to be honest. There's also, if we go over here, you see angle. So now we can rotate, or if you go to one of these 4 cardinal points, you can scale. So transform, rotate, scale, or you can edit them directly in the inspector. So editing is quite simple, it's quite straightforward, etc. Now let's go ahead and actually add one more component to this guy. So go back to our logo, go new, and we're going to go ahead and add a physics component, a rigid body component here. And the physics basically are now attached to this object, and that was all that was required. I go ahead and I press the play here. Oh, I haven't saved my scene yet. Click this button, save your scene, and you'll now see that your scene is part of the project. So we could go ahead and also create another scene, save it, and we can come in here and rename this guy to second scene. So your scenes are ultimately just assets as well, and whichever one you select is what is shown up here. But I didn't save the scene, which is why it wouldn't go ahead and play. So now that I've saved the scene, go here and press play, and you see, boom, physics are attached to that object. And we can go to that component in an inspector. You can see inside the rigid body the typical settings you would expect with any physics engine. You can set your dampening, velocity, friction, does it ignore gravity or not, velocity, linear velocity on it, set its mass, its restitution or bounciness, etc. So your typical settings are all here. Additionally, you can change its type between static, dynamic, kinematic. Difference there being static doesn't move but can be hit or interact with other items in the scene. Dynamic is pretty much a normal, fully simulated type thing within the simulator. And then kinematic is generally used for your character, where you're going to be providing the input directly, and the world is going to respond to that unit. So those are your 3 different settings. Now we can also define the physics shape. And if we had multiple things here, so let's go ahead and do that. We're going to create another one. I'm going to vary a little bit from what I did in on Gamefromscratch. So back to our editor here. I'm going to show you a couple more things you can do with the editor. Is your middle mouse button, and then direction pans the scene like so, and scroll wheel zooms the scene. So I'm just going to grab this guy, move him up a bit, and I'll just take my logo again and drop another one in. I'll scale both these puppies down because they're both pretty big. So, and we're going to take this guy. Let's give him a better name so they're not the same. And we shall add physics to him as well. But this guy ignores gravity. So now our simulation can actually do something. And these guys can be used to preview your scene. So you can sit here and we can actually see how things would respond. And let's go ahead and I'll show you now. Make that second guy static. Now, you notice something there. We went right inside of our shape instead. And that's because our default shape is actually a bounding sphere, or bounding circle, not a box. So what we want to probably do is edit the shapes for both of these. So stop our scene, pick our first shape, come on up here, grab rigid body, go over here into rigid body editor. You'll see it's a circle by default, and it doesn't match the shape that we've scaled up and screwed with. So we're going to go ahead and delete that guy and grab this guy right here. And you can just quickly define the polygon, and then right click to finish. Now we're going to go ahead and grab the second guy, rigid body, delete, delete, and define its shape a little bit more precisely. Right click, done. So that's where the rigid body editor comes in. It's for defining physics volumes. Now you also notice when you have one set, when you have a physics body set, there's also a couple settings you can set over here. Density, friction. Is it a sensor? A sensor is basically, it goes in the physics simulation, but it's just there to be triggered. It doesn't really do anything, but things can hit it and it can potentially hit other things, but it doesn't change the simulation. A lot of times it'd be used for things like the finish line or out of bounds, etc., stuff like that. Or literally as a trigger to cause something to happen when something goes through it, but it's mostly linked to code. Now that we've got that done, let's switch on back to our scene editor, and we can hit preview. And now, all right, I didn't do the cleanest definition you've ever seen, but it is a little bit closer. Now let's, all right, I actually did something wrong there. Let's switch back to the physics editor for a second. I'm not sure what I particularly did wrong there, but oh well, I'll figure that out at a different time. I've obviously made a mistake at some point here, but let's stop our simulation and I'll show you just quickly. There's also here game view, and game view is, it's a non-editable. When you're in here, settings change that you make do not stick, so you can play with it and change things around to see how they like, but they're not permanent settings. And the other thing is it gives you a bit more of a real result of what you're working on. So let's go ahead and press play here. We can just see the same thing going on and done. So that's the editor environment. As I saw, the nice thing, as you saw with the materials, the shaders, the hiding, it's hiding a lot of the complexity for you. It's figuring out things for you, but whatever you want to do is ultimately there. There's a couple things that are tucked away in menus. These two guys, application data, it's things like where you set global data that, you know, how sound's going to work. Is physics updated at a fixed time interval? The title of your application. And then over here you've got basically your window settings. Anti-aliasing on off, your default dimensions, windowed or not, vsync honored or not, etc. So that's kind of the last of the settings you've got available to you. And then beyond this, now it's code time. And code time is very, very, very fun. Well integrated, well done. So let's head on over to that now. Last thing I want to show you though, I didn't actually go through what components are available. You see here, oh actually, you know which one would be very handy right now? There is a component in here for debugging rigid bodies. So go back to our scene editor. So we'll grab our first entity right here. So GFS logo 1 and new component. So you have a diagnostic renderer. You have these 5 graphic objects. One's for rendering text. One's for sprite, we already saw. One's for animated sprites, which is if you had a sprite sheet. Super easy to use. If I've got time, I'll cover that very quickly later on. The camera we've already seen. And a rigid body renderer, which is for debugging your rigid body definition. I'll turn that on in a second for both of our objects so you can see it in action. Physics, we saw our rigid body. And sound, you can have it so something can hear sounds and something can create sounds. And adding sound is actually that simple. So if we wanted to, say, beep from our guy, we could easily just add a sound emitter on this guy, set the beep sound up, and then control it however we wish to do so, or automatically. So those are your components out of the box. So let's go ahead and we'll add that graphics one for rigid body renderer. Now we'll grab this guy and add new graphics rigid body renderer. And this should give us some idea of what is going on. Now the rigid body renderer is, see that white outline around the outside edge there? And we could configure that as a property, rigid body renderer. We could change that color to, say, bright red. And bright green. And I got no idea why that's happening. Okay, so the debugger didn't help us, but you can actually see that component in action, and then you can just as easily get rid of that guy again with a delete. And you see it's immediately gone here from the preview. Now we can also go ahead and actually run our code. So far we've just been running it in the editor. To run it, just press this guy, or to debug it, press that guy. So we'll just go ahead and run instead. It goes off, does its compile, and there you go. I think that's a good hint. There's something wrong with that second image. I'll kill it all the way anyways. So run your game, click this guy, builds it, does its thing, and there it goes. Now, if we want to code our game though, we just click this guy and it will load up Visual Studio. You could have also gone and opened that solution file I showed you earlier on. Either approach gets you there. It's not a big deal. Now, the heart of your game is actually here. You see, there's core plugin and custom types. Now, what this ultimately boils down to is your game runs as a plugged-in DLL to the executable bootloader, and then all of your stuff within your game is implemented as components. So, first guy is your core plugin. It's just that. And now you could have also created plugins that go into the editor. You can extend all that stuff, but your game is ultimately a plugin itself. And here's where you'd put your global game logic, things that affect the game on a global level, or that are persistent across the life of the entire game. But most of your logic is actually going to be done as components. So you see we've got this, your custom component type. And really all it is inherited from component. That's all they've done. Now we go ahead and just do a build. And we're done. We just finished building. And the key thing is that it copied these files over. So now we go back to the editor. No changing, no reloading, no doing anything else. I can now go back to scene editor, grab our guy right here, and if I go new, you'll notice now there's a new component type by our namespace Duality, and then I can attach the component that we just created to this guy. And that's it. That's how easy it is to integrate your own custom controls or custom components into the system. And now let's actually go ahead and do that. So what we're going to do is we're going to get rid of the rigid body on this guy, like that. And all I want to do is go ahead and add a WASD controller. So on the WASD keys, we're going to respond accordingly. And that is a simple process. So first things first, we need to come in here, back to Visual Studio, and we're just going to go ahead. We could reuse this your custom component type, but we'll actually, you know what? I'll just rename that. Actually, I don't know if our name is going to cause problems. I'll just, oops. I'll add a new one. So, add a new class called WASD controls. And the key thing, same with this guy. So you want using duality and your inheriting type component. So, like so, and component. And that's it. So now we can actually have our component in the game. But the thing is though, I want to do a little bit with our component. I want a component to have a bit more of a life of just being something that exists. In fact, I want it to be part of the main game loop. I want it to have an update method. And to do that, we just implement this guy. So ICMP and updatable. Now, if it was a drawn component and we wanted to have a render method, we'd implement renderer. And if we wanted an initialization method, we would use initializable. And actually, we're going to go ahead and we're going to add one of those too. And then you just have it implement it. So we now have an init and a shutdown, and we also want update. And again, just let it implement. And we don't want to blow up, so get rid of all those things. Now, remember earlier when we added the one component, it automatically brought in another one. There was a relationship and a dependence there. Well, we can also say that this component has dependencies, and that will create that same relationship on that side, but it will also cause it so that we can reliably depend on this component's parent also having that other component type as a child. So in this case, we're going to say we need to have a transform effect because we're going to ultimately affect the transform component with our WASD component here. So we're saying we require our parent entity to have a transform component. So first off, I'm actually going to need another using. So using duality components. So, and it can be done using an attribute called required component. And you just pass in which one you require. So transform. So basically we've just said this component requires that component to function. And now if you delete that transform component from it, this will get deleted as well. And in code, we can always assume that that transform component is going to exist. So now that we've got that, we're going to do some of this. Some of this is just to show you can use initialization as opposed to a smart way to code. So create a position method that's private, and so right off the hop, we'll set our position to 0, and shut down, we don't actually do anything. So this is our update call. On update is going to be called every frame, every pass through, and this is where you're your component will do something. Again, if you were going to be doing a draw though, so every rendering frame, you would use iDrawable as opposed to iCMP updatable. But let's go ahead and do our update. And here what we're going to do is get a reference to that required transform component. And this is done through game object, which is the game object parent of the component. And then we can say get component, and we can say of type transform. Actually, that's all. So we just got a reference to the transform component attached, and let's reset our position X each frame. Why did I do this? Oh, because position is poorly named. Position should actually be called move by. This we're going to increment our position relative to. There's a very bad naming on my behalf. I'm matching the code I did on Gamefromscratch, and I did some pretty horrible code, to be honest. So first off, we're going to pull in to get some keyboard results, so see if a certain key is pressed. And to do that, we use the Duality app global. And this is where a lot of Duality game engine is actually exposed. So you can see here, you get the path, debug object, you can get graphics, gamepads, joysticks, etc. The window. Now in this case, we just want keyboard, and then key released. Now you also notice we also have key down or key up, so we could also use events to handle this if we'd prefer, but we're going to pull in this case. So if key is released, and W, and then position Y. So if they press W, we go up, or technically down. Oh, great job on the code completion, guys. Visual Studio can be frustratingly stupid sometimes. So we're going to do our full WASD. So A and S are left and right, and D is down. So no, S is down. Sorry, my bad. So that would be Y. Moving back to X and plus. In theory. All right, so now what we're going to do is just take that transform component, and we're going to use the move by method of it to move it by our position, like so. So all we're really doing there is moving by up, down, left, or right, 10 pixels per key pressed event. And we can also run it from here, so go ahead and press, oh, got an error. Oh, yeah, don't do that, my bad. All right, so that is now built. Now it's not gonna do anything because it's not attached to anything. So now let's go ahead and grab our object here, right click, and you will now see new Duality. Why are you not there? Save all. Oh, yeah, I do this every time. Public, build that. Let's head on back. Right click, new Duality, and there is our component. Attach it, and we now have WASD components attached to our object. We press play. Actually, I don't think you're going to get them that way, but we should get it in game view. If I focus, yeah, whoa. So there you go. And if we want to do full on blown simulate, actually go ahead and run it. And there you go. And the cool thing is that WASD component can be attached to anything in the scene. So in theory, I could actually attach it to, so we can take that off of our logo here, instead attach it to our camera. So our camera now has WASD controls attached. Now, the end result looks exactly the same, but we're not actually moving around our entity anymore. We're moving around our camera's view of it. So everything is sort of reversed to it. But that shows how strongly, you can decouple your components, but you can very easily reuse them as well. So your programming interface between the two is very clean, very simple. You have quite a bit of access to things using this Duality app implementation. All of your familiar C#isms are there, so we can do things as events. We could use async if we wished. We could, oh, actually, we may not be able to. Don't quote me on that one. The integration between the editor and back and forth is seamless. I've actually never seen a C#-based game engine that just worked like that. Other than the fact I forgot to put public in here, there was no like I always had the reflection capabilities of both Wave Engine and Paradox bombed at some point. Where this one just brought it over. With the other ones, I had to sometimes load and close my project, bring things in, etc. This one is seamless and flawless. And you can also, and I'm not showing it here now, but you can also do integration back so that values can be set on your custom components inside of the editor. So it's a very powerful setup for sure. But I'm also running out of time, so I got to wind this down a bit. Obviously, I'm not going to get too deeply into coding, but you can see the basic process here. Your stuff exists as components or as one big plugin that controls your quote-unquote game, and then these various different components that make up your... And you also could have it where your component was, you know, there's nothing involved in the creation of the other, and you could have your player, and your player could be composed of sprites and animations and all those different things. Very quick, very powerful, very cool stuff. I will show one thing before I finish things off, and that is how easy sprite sheets are. So you can see a slightly more advanced example in Power here. So go back to Scene Editor. So first things first, we need a sprite sheet. So I'll go over here to my downloads. High Fantasy. All right, you'll do. So bring in the sprite sheet. Ooh, I do not like that file name. Let me just change that out just in case. So you see, came in. It's got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 frames of animation. So in this one, I could just say, okay, so that's 3 columns and 4 rows. So we now have the various, it knows to deal with the frames. I can now new, hell, I'll stick with that name. New graphics, and we use animated sprite renderer instead, like so. We just drag our sprite over here, and you see it automatically figures out the dimensions we want. And now I can just say how long that animation lasts. That animation lasts for 1.5 seconds. The first frame is 0. There are 9 frames of animation, and loop when you are done, like so. Go ahead and play. And that is how easy it is to bring in an animated sprite sheet. So I've been showing you very simple stuff so far, but you can do very powerful things, very quick, very easy in Duality for sure. So I definitely underrated this guy. These tools are very polished. The process, the workflow is very polished. Now what I want to cover before I finish things up here is the support and the community and all of that. And that is where these projects fall on their face every single time. They normally have crap documentation. This is not a really well-known project, so the community is not going to be huge, etc. I have so low expectations, and again, I was wrong. The documentation rocks. First off, finding it can be a bit of a trick because it is located here only. I did not find this on the web. So you've got the Getting Started guide is here. This is your wiki. All right, why did you... here we go. You've got this wiki to get you started. It is very minimal, not a ton there. It covers creating game mobs, basically what you just saw here. It covers most of that stuff in a frame-by-frame basis. But where it's really impressive and very hard to find is in the... All right, where the hell did you go? Okay, F1. There we go. So it's got this great documentation, which is not available online, which is a little tricky to find. It's actually just F1, so I should have just intuited that. But this is your class reference, and class reference is always the most important thing to me. And you shall see that it is not only well implemented, but they actually took the time to put real descriptions of the majority of objects in here. And just see if I can... You also have an idea here of how much is there from a code perspective that I haven't even touched on. There's a lot to this engine that I didn't even... It is a full 2D game engine. Everything you would expect is in there. There's a lot of support that I never touched on here at all. But let me just... Good example. Yeah, those are all pretty bad. But what you will find is ultimately the information shown here is the same as what ultimately appears up here when you're dealing with an object. So this is the velocity comment for that particular component, etc. But there was a full, thorough reference material. It's served me well every time I've gone to need it. So that part is definitely nice to see existing. And next up then is back to the community. And here, there's the wiki. There's this forum. As you can see, it's fairly active. And people do a good job of actually responding to questions. You see, and this is the way you can always judge how good a forum is you come in and you look at replies. And if you see a lot of zeros, you're in trouble. Because that means someone asked a question nobody bothered to answer. And don't get me wrong, there's a lot of places that a lot of stupid questions get asked, and a lot of times the community just gets sick of it and never answers. Every single time I looked up anything, there was always an answer, and generally always a good one when it came to duality. So there is a strong community out there answering questions as they come. And then finally, let's go on back, and here we go here. We've got your source code, again, is available on GitHub under the MIT license. And this is also always a good sign. It doesn't say 46 days ago or 7 months ago or 9 months ago. This is an engine that is being actively worked on a lot. It's an engine that is remarkably polished with remarkably polished tools, that works well, that has a great workflow. I am really impressed with this guy. So I recommend, highly recommend you check this out. End result, end summary, it's 2D only. It's got a very good editor that does most of what you need. It's got nice code integration with what, in my opinion, is the best IDE out there. And that's a strength and a weakness, because sadly that tooling is also Windows only. And the nice thing again is that porting job to make it portable class library, so this code should run anywhere. So being a Windows only engine isn't a thing anymore. Now you can create code for just about every platform out there, which is a big win. So if you're doing your development on Windows, regardless to which platforms you want to support, if you're doing 2D only and want solid tooling and want to work in C#, Duality is a great choice. God, compared to the alternatives, it might be my #1 recommendation when it comes to C#, especially for 2D. It's got... You could do the same thing in the other engines out there. You could do it in Unity or Wave Engine or Paradox. All of those guys can do the same stuff here, but in a more complicated way. This focus on 2D, the streamlining of the tools to be 2D, pays dividends. So if you are working in 2D, this is like picking the right tool for the job, and it fits very well. So if that is what you're working on, if you are working in C# on a 2D game, I highly recommend you check out Duality, as long as that platform issue isn't a huge issue to you. If the tools need to run on Windows being a deal breaker, that deal is quite thoroughly broken. If that is not an issue, I highly recommend you check out Duality. It's one hell of an engine. It's right up there in my recommendations with Godot and libgdx. I'm shocked by how much I like it. So you owe it yourself. Check this guy out. Great little engine. I wish I saw it earlier. Thank you very much. See y'all later.